Section 12.2.1 is titled, How Can I Rewrite It? And the subtitle is Trigonometric Identities. By the end of the lesson, you will be able to discover trigonometric identities graphically and use those identities to rewrite and solve equations. So for the warm-up, the first thing I want you to do is to use the graph to determine if the equation 2 sine of x cosine of x is equal to the sine of 2x, and state whether it is sometimes, always, or never true. So you're going to graph both of the sides in Desmos and then write your observation. So pause the video, go to Desmos, graph each side, and see what happens. All right. Question 72. It says, consider the equation 2 sine of x cosine of x equals 1/2 for x when x is between 0 and 2 pi. We currently do not have the tools to solve this equation algebraically. Instead, we want to use the result from the warm-up to rewrite the equation 2 sine of x cosine of x equals 1/2 as an equation and solve the equivalent equation algebraically below. Okay, so if you did what I asked you to do in the warm-up and you went in and you graphed them, you would discover that they were always true, meaning that this graph was completely on top of that graph, and therefore 2 sine of x cosine of x is equal to the sine of 2x. So we can say that the sine of 2x is equal to 1/2. Then you're going to calculate where the sine of 2x intersects the 1/2. So if you go in to Desmos again and you type in those two equations, here's what you're going to get. Here's your sine of 2x, this right here. And then here is the line y equals 1/2. And you can see between 0 and 2 pi that they intersect here, 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 and here in 4 spots. And so I just wrote those down. One was at pi over 12, one was at 5 pi over 12, one was at 13 pi over 12, and one was at 17 pi over 12. And so your solution to problem 72 uses what is called the double angle identity, which says that the sine of 2x is equal to 2 times the sine of x cosine of x. And if you flip over to page 17 in your math notes box, you're going to have listed a bunch of trigonometric identities. The one that we just used is right here. It's called a double angle identity, where the sine of 2x is equal to 2 times the sine of x cosine of x, but you can see there are a lot of trigonometric identities. All right, so back on page 16 on problem 75, it says, recall that cosine squared x plus sine squared x equals 1 is called a Pythagorean identity, is one of the most useful identities you will learn. Work with your team to explore the following questions. Why do you think the cosine squared of x plus the sine squared of x equals 1 is called the Pythagorean identity? And explain the connection between the Pythagorean identity and the Pythagorean theorem. A squared plus b squared equals c squared. So the identity is the Pythagorean theorem applied to the unit circle. Two more very useful identities come directly from the Pythagorean identity. To discover the first related identity, divide both sides of the cosine squared x plus sine squared x equals 1 by cosine squared x. Simplify and write the new identity below. So if we divide this by cosine squared, we're going to get 1. If we divide this by cosine squared, we're going to get tangent squared of x. And if we divide 1 by cosine squared of x, we're going to get the secant squared of x. And then in part 2, they want us to discover the second related identity, this time we're going to divide by sine squared of x. So when we divide cosine squared of x by sine squared of x, we get cotangent squared x. And when we divide sine squared x by sine squared x, we get 1. And when we divide 1 by sine squared x, we get the cosecant squared of x. Again, these are all with your trig identities that you're going to see on page 17. And up at the top it says there are many different trigonometric identities. These identities are listed below. Use these identities to solve trigonometric equations algebraically. So we're going to do 2 together, and then I'm going to have you try the third one by yourself. So go ahead and turn over to page 18. All right. So on page 18, we're going to solve the equation from 0 to 2 pi. And so we're going to take the equation, -3 sine of 2x equals the square root of 2 cosine of x minus 2 times the sine of 2x. So the first thing we're going to do is we're going to expand using the double angle identity. So anywhere we see this sine of 2x, which is here and here, we're going to rewrite it as 2 times the sine of x, cosine of x, and then we're going to do the same thing over here for this second piece, okay? Then we're going to calculate, meaning we're going to multiply what we've got. So -3 times 2 is going to get us our -6 there, and -2 times 2 is going to get our -4 there. Then we're going to move everything in this equation to the left side, and that sets it equal to 0. Then we're going to combine any like terms. So I have a like term here and a like term here. A -6 sine of x cosine of x and a +4 sine of x cosine of x. Those two combine to get our -2 sine of x cosine of x. And then the next thing we're going to do is, because this term has a cosine of x and this term has a cosine of x and they're both negative, I'm going to factor out that negative cosine of x, leaving me with 2 sine of x plus rad 2. I'm just going to swap the sign here, and then I'm going to list my 2 cases. So I need to solve for when cosine of x is equal to 0, and for when 2 sine of x plus rad 2 is equal to 0. I'm going to subtract that rad 2 and divide by the 2, and then I'll have different answers. This one on your unit circle is going to be pi over 2 and any multiples, and then this one is going to, off your unit circle, is going to be 5 pi over 4 and 7 pi over 4 and any 2 pi multiples. All right, problem number 2. We're going to expand using that double angle identity again. Then I'm going to distribute this -1 that's right here that you can't see. So distribute it out. That gets rid of the parentheses. I'm going to combine my like terms because I have these guys over here. That gets me my -1. And then we're going to move, and use that Pythagorean identity, which says that sine x squared minus cosine x squared is equal to -1. Then we're going to move our terms around. So I'm going to take the cosine of x, move it to the left, take that -2, add it to the right, and then I'm just calculating here. -1 plus 2 is 1, and then because I have opposites, I'm just going to switch my signs, and then I'm going to look at my unit circle to see where the cosine of x is equal to -1, and that will be at pi. And then we're going to have any multiples of pi every 2 pi. So you guys are going to try number 3. Use the trig identities that are on page 17 and use your unit circle. Then when you're done with number 3, you can work on section 12.2.1 on your review preview.